Hello, and thank you for joining this ETSI webinar. I am Emmanuel Boswordic from the ETSI events team, and today's webinar will focus on OSM Release 16 towards cloud-native orchestration of cloud services and applications. Our webinar will be presented by Francisco Javier Ramon Salguero, ETSI OSM Chair Telefónica. Welcome, Francisco Javier.
Hello.
Gerardo Garcia de Blas, OSM TSC Chair Telefónica. Welcome, Gerardo.
Hello.
And Ramesh Ramanathan, TSC member of Tata. Welcome, Ramesh.
Hello.
This webinar will present some of the most relevant features of OSM Release 16. It will last up to 60 minutes, including Q&A. If you have any questions to your speakers, please submit them in the questions box, and these will be addressed at the end of the webinar. After the presentation, of course. The webinar will become available on demand shortly after the end. But I think now it's time to find out more about OSM Release 16, and I am pleased to hand over to Francisco Javier. Francisco, the floor is yours.
Thank you, Emmanuel. This new release of OSM, the Release 16, marks a very significant milestone in OSM's journey. Why? Because it means a revolution in the OSM scope, the architecture, and the functionality. So we wanted to make sure that since there are too many additions, more than in usual OSM releases, we wanted to illustrate it during this webinar. So we wanted to explain them and demonstrate them so you can see these features in action and what they mean for an OSM user. So as I was saying, I mean, the scope of OSM has been significantly extended because now we are managing not only the application, but also infrastructure and platforms. And we do that across cloud platforms, as we did in the past, but now incorporating all those components. And as always, with the objective of making that deployment and maintenance as easy as possible. So we are abstracting the complexity. In the description of what OSM does, there are no substantial changes because our goal is modeling, abstracting, and making things much simpler to operate. But now we are adding the component that is highlighted here in yellow of incorporating the cloud infrastructure management whenever that we need to. Okay, it's not mandatory, but it's quite convenient in many cases, so that we wanted to take it into account. And that translates into a lot of new features in this release. I will not go one by one by each of them because it will be the subject for a whole series of sessions. But I want to draw your attention on the highlights, on the main themes that have been added in the release. The first one is the cloud native operations in OSM. This is a big deal and will be analyzed thoroughly during this webinar because this is the game changer in the architecture of OSM and is enabling a lot of functionality. Also, the management of Kubernetes clusters. As I said, we are also incorporating in the framework the management of infrastructure resources and platforms. So this is the first type of platform, Kubernetes clusters in public clouds of PaaS type. Will be the first of many. And in spite of having all these new additions, new architecture, we are not forgetting the progression of the features that already existed in OSM traditionally. So we have added security enhancements. We have improved the experience of the use of OSM, adding better abstractions and better means to tag the components in OSM. And also we have preserved smooth OSM installation for anyone who is experiencing with OSM. They don't need to do any complex preparation process for using OSM, in spite that we have added many functionalities, many new components, many new relations among the components. That's all abstracted and simplified from the end user perspective. And I would say that the experience of installation is better than ever. So we are quite proud of that as well. Why I'm saying that OSM has extended the scope? Well, if we keep an eye to what OSM was until release 15, was mostly oriented to imperative operations, NFV-like. I would not say this 100% imperative, but I have a big component of imperative way of work. and also that it was combined with the day one and day two actions that OSM added. That is preserved. We are not forgetting about that, but also we are incorporating a complementary way of work in OSM that is based on declarative operations that are based on configuration of data. So the intents are managed as data. The operations are Kubernetes-like, and we can guarantee that there is a continuous reconciliation between the infrastructure and our intents. So both collaborate together now in OSM to provide the best experience for all the use cases. What do we mean by those new declarative operations? Essentially, what we mean is that the intent, the desired state will be stored in sources of truth, and in the target clouds, between that sources of truth and the target clouds, will put in place a mechanism that will adjust and make sure that the clouds are in sync with the desired expressing the sources of truth. No matter if we are changing the desired state in the sources of truth, no matter if there's been any circumstance in the cloud that deviate them from our desired state, so we can recover from there and put them in sync again. Okay, and the thing is that this brings a lot of advantages because provides a very safe storage of all the intents. Actually, we can version them and have the time machine of all of them in the past, so we can do rollbacks or check even the authoring very tightly or providing advanced access control very easily. And on the other hand, this reconciliation of intents is not magic because the base technologies already exist and are mature enough. We are talking about Kubernetes and we are talking about GitOps tooling that can be naturally applied here in the benefit of this purpose in OSM. Actually, that will allow us to focus in OSM and where we are adding the complexity, the management of that complexity. So OSM core above will be in charge of decomposing the high-level intents into low-level intents. And those level intents are committed as transactions to the sources of truth, and they will be in sync. And in order to change those intents, it will conveniently expose an Orban API whenever it needed in the traditional way of working, although it's not mandatory, but we still provide that convenience. And at the same time, we can also provide our own operators in case that the description of the intents that exist in the ecosystem is not sufficient for the OSM purposes. We can always provide our own operators to do that synchronization as easily as possible, as conveniently as possible for the purposes of OSM. So this declarative operation, whenever that can be applied, is not in 100% of the cases, but in the cases where it can be applied, is very elegant and solves many challenges, practical challenges for large deployments. So the first is that it removes any ambiguity about the desired state because it's always captured. It's the starting point of everything, right? A new deployment is copying the state. The rollbacks are very trivial. It's coming back to the previous transaction, and debugging is very, very trivial as well. And we don't need a complex choreography of determining what was the state of one deployment. It's very clear from the very beginning. On the other hand, the onboarding is much simpler, particularly for cloud-native components, which are designed to work in this way. So we are not doing any strange NFV-like adaptations because the artifacts can be already used as they existed. So they can be incorporated in the system as we will see in a minute. Okay, so the learning curve is much shallower and more natural. And from the perspective of the evolution of the platform, this is give us the advantage of not only relying on Python libraries for high-level functionalities, that is good, and we'll keep doing that for sure, but also allow us to choose between Python libraries and existing Kubernetes operators. So the combination of them give us a lot of high-level support for the management of cloud resources and complex operations. So this mix is definitely much better combination than we had in the past. During this webinar, we will be covering how this works behind the hood and how, from a user perspective, you will be using these concepts in the new OSM. Later, Gerardo Garcia will show how these components work in practice, and I will run a demonstration so you get the feel on how these components, what is experience with OSM. And in the last part of our webinar, Ramesh Ramanathan will illustrate this usage with a full 5G use case. Okay, so we have a busy agenda, as you see. So as we were saying, I mean, the key for keeping the resources in sync is not magic. It's that we can simply put a management cluster in the middle and putting the right operators in the middle. So on the one hand, Flux is in charge of coordinating that cluster with the sources of truth. That is a given. And on the other hand, in case that we need to interact with clouds and sites directly, we can leverage on crossplane and cluster API, mostly from the management cluster. And that creates this channel that we were showing in previous slides. So if I put an intent on the left, it will be propagated to the right automatically. And we can benefit from that. So we can focus on what actually matters. And the thing is that at this point, you might be wondering, okay, perhaps naive GitOps is enough. I mean, working at low level should be enough. Well, it's not that simple. In a large deployment, in large realistic deployment, it's not that simple. First, because you need to grant some synchronization order. I mean, not all the resources can be, all intents can be put together in a specific cluster. Or the most simple example is that if we are creating new clusters out of the blue, we need to make sure that the cluster is ready before trying to put CNFs or applications on it. So we need to wait, and adding that wait is doable, but it requires some effort. Also, if we are in a large deployment, that can lead to massive duplication of intents that are almost the same. So maintenance of those intents that are almost the same is complex, unless that you put the necessary resources to manage them conveniently. Also, is that if we have sensitive data, we always want it to be encrypted and preserved as much as possible. The last thing that we would like is pushing a password or a credentials in a Git repository, for instance. We need to put the necessary mechanisms to avoid that. And also the creation of the resources in the clouds is not as simple as it sounds. There are many subcomponents, so creating a cluster can involve up to 18 or 19 components to be incorporated in the cloud. So that requires some coordination. And also the bootstrap of remote cluster. What do we mean by this? Is that now OSM has the capability to even create new clusters out of the blue. Those clusters are containers where they can host new workloads on them. So we need to make sure that after we've created a cluster, that cluster can be incorporated to this framework again. So in turn, we can deploy workloads on it. So that process is far from being trivial, even less in recovery scenarios. So under these premises, this complexity is growing widely with size. So here is OSM to assist you. Okay, but it doesn't want to interfere in the framework. That is the equilibrium that we want to get. So we have introduced some concepts that will help you to do that. The first one, the most basic one, is the KSU, the Kubernetes Software Unit, that, as its name says, is a set of manifests that can be deployed in a Kubernetes cluster. That can be based on blueprints of OSM. But the point is that we are not applying them directly. That would be naive GitOps. Instead, what we are putting them into what we call profiles. A profile is a collection of KSUs that can be synchronized together. So we put those KSUs, we ask the user to put the KSUs in different profiles. And each of those profiles, everything that is in the same profile will be synchronized together. And they will be attached to synchronization layers of a cluster. So let's analyze how we are modeling the cluster. The cluster has, each cluster in OSM has 4 layers of synchronization. So in the cluster, first the infrastructure controllers that need to be ready before anything, then the infrastructure configurations that depend on this, and after that is when we are ready to deploy either applications or any cloud resources in case that we are in a management cluster. The trick here is that our profiles can be attached to these layers of synchronization, so OSM will be in charge of automatically deploying them in the right order. We can attach multiple profiles to one layer of synchronization. We can attach one profile to multiple cluster intents. That's the trick. So that simplifies the picture a lot, as we will see in the next slides. Okay. Just a bit of zoom that will not be exhaustive here. I mean, just providing some examples of what we mean by the infrastructure controller, infrastructure configurations, and all the like. So is what you would expect, the components that are needed in order to have a production-ready cluster available and putting some applications or Kubernetes objects representing cloud resources. Okay. So let's understand this by an example. Suppose that we have managing our management cluster, and we have touched here in the profiles here in yellow in the infra controllers. So we have it ready. If we want to have control over these two clouds, we can add some infrastructure configurations. Okay, and if eventually we wanted to create a cluster, say in Azure, we will create some cloud resources here and a cluster intent structure here for controlling that cluster later. So that will lead to having a cluster that is created here in Azure, and eventually that cluster would be bootstrapped and tied to this structure. What will mean that this cluster will be obeying what is the intents that are added to this infrastructure. Cluster intent, okay? If eventually we created a second cluster, well, first we can deploy applications, just adding them in the cluster intent, as you see, the OpenAir interface. And as I said, say that we wanted to replicate this in Google Cloud in another cluster. First, bear in mind that we have profiles attached to this layer. So we are not touching the layers directly. We are touching the profiles, and we can use that in our own benefit. So in case that we created another cluster in Google Cloud, and these were bootstrapped to be controlled from its own cluster intent, we can attach the profiles also to this cluster intent. So automatically, the same application will be deployed in the other cluster. And if eventually say that we wanted to upgrade the OpenAir interface, we just need to change, update the KSU in the profile number 3, as you see here, and automatically that will be propagated to all the clusters where that profile is attached. Say that you have 100 clusters in an edge deployment put there, they will be automatically propagated and upgraded in one change. So that is the benefit of the new framework. And now Gerardo will present you how this works in practice. So over to you, Gerardo. Gerardo, you are mute.
I was not able to control the mute. Now I think that I'm audible, right? Thank you. So yes, now let's go to a live demo. I'm going to illustrate the new release 16 components. So the new components have been added to OSM and the GitOps workflows that we have added in OSM, right? So basically there will be two demos, one of the new components and the other based on the GitOps workflows that we will illustrate for different use cases, right? So I will start with the new components. So as Francisco Javier has mentioned before, the main novelty is that OSM has been transformed into a GitOps system with Flux. That means that we are making changes in a Git repository. Flux is reading them, and those changes are later on applied to the different clouds, right? For that, it has to be clear that all the new operations are declarative and are modeled as Kubernetes objects. That means that all the infrastructure, the classes that we are creating, are modeled through, obviously, in this case, crossplane, CAPI, okay, CRDs, that are extensions to Kubernetes. We have also added the crossplane CRDs that allow us to create platforms. We have also the capability to create network functions and network services. In the end, with Flux customizations and health releases. But not only that, not only we are able to create infrastructure, platform, and services, that even our own workflows in OSM, we have decided to implement in a declarative way using Argo workflows. Okay. So, and all of them are deployed in a management cluster. So somehow the management cluster is here coordinating desynchronization with the Git repository and also adjusting and applying the changes in the different clouds and sites. Okay, that's more or less the summary. Just to make sure that we are on the same page here. So I'm going to start with the new components. So basically in OSM architecture in release 15 was consisting of the modules here that you see. Okay, we have an MBI that is the one offering a REST API that is consumed by a CLI as OSM client, and also a graphical user interface using that REST API. MBI is in charge of distributing, or it's managing all their role-based access control And if the user is allowed to do an operation, then the operation is published in a Kafka bus and is consumed by the different components, mostly LCM, lifecycle management module, that is in charge of running the workflows. And in case there is a need to interact with the clouds or with the beams, the resource orchestration was in place. In addition to that, we have a set of common services that are well, databases, etc., that are used by all the modules. And also we have components for metric visualization, such as Grafana, and also the component that is in charge of the service assurance workflows, that is Airflow. That was part of release 15, nothing new. This remains. But what we have done is that we have taken those OSM components that we have in release 15 and we have added some new components. So the first one, obviously, if we want the GitOps model, and that's what we have incorporated in OSM in this release, we need some Git repositories. And for that, we are provisioning GitEA application. GitEA is a well-known open source project that allows you to have your own Git repositories, and we have created in that GitEA the appropriate users and repos to be used and consumed by OSM. And in addition to that, we have added all the declarative framework. That means the continuous deployment operators such as Flux, the CRDs that will allow us to create clusters in this case, and basically the CRDs from Crossplane, and also the workflow engine that allows us to run the workflows in a declarative way using Argo workflows. That's the declarative framework. And there are different deployment options. So we have these three set of components: the OSM components, the Git components, and the declarative framework. And one possible deployment option is to have an all-in-one installation, everything in a single Kubernetes cluster. That's what I'm going to show you, and that's the default installation when you use the installer that we are providing. But besides that, you have another possibilities that you could, for instance, think that it could be practical in production deployments to have them separately, and that's also another possibility that you can do. Okay, you could have an OSM cluster with only the OSM components, the management cluster with all the declarative framework, and the auxiliary cluster with the workflows. Sorry, with the Git repositories and the Git application. Okay. Well, so let's see, now that we have seen that, let's see what we can see in an OSM installation, okay? So I'm going to share my screen now. Here. I hope that you could see my screen. Well, this is a console screen, okay? I hope that you are not afraid of that, okay? Because in some cases I will use it for the interest, right? So I'm just going to check here what do I have when I run an installation of OSM. Let me, now I think it's here. Let me, for instance, show you the nodes. So this is an OSM 16 installation, and if I check the nodes, I can see that there is a single node, basically this virtual machine, okay? And we are running here a K3s Kubernetes cluster. That was one of the features that was added in this release. So we are running the default installation is on a K3s Kubernetes cluster. Then let me check the namespaces that we have. So you see here some of the different components that I mentioned before. So for instance, all the components that we have in previous releases are under OSM namespace. We have also added an ingress nginx that is exposing all the services that we had in OSM through an ingress controller. We have GitEA. This namespace hosts the GitEA application where we have the Git repos created. We have Flux system, that is the one with that has Flux, the continuous deployment operator. And we have also here, for instance, this namespace is contained in all the CRDs that we are adding to enable cross-plane in the management cluster. In this case, in this same cluster, and this namespace has all the CRDs for Argo workflows. Okay, so all the new components have been added in different namespaces. Now, let me, for instance, start illustrating the ingress that we have added. Okay, this is I think it's relevant because in the past we were offering everything through a load balancer, and now we are offering everything as ingress endpoints. So you see here the list of endpoints that we have. So this is for instance, the UI. Okay, so if you want to access to the UI, you just need to go there to the UI and just click on here, and you have the UI interface here. In addition to that, we have all the service assurance, the Airflow, Prometheus, Grafana, everything is also exposed here. So you see here, for instance, Airflow running with all the workflows that we have for getting metrics from the VIMs and the VMs. You have here the time series database, Prometheus, okay, and we could access to that. And we have here Grafana with the dashboards that we want to show, okay. So I think that, well, this is one of the main things that was added in the release. I would like also to bring your attention to the fact that since now everything is exposed in through Ingress, we need to use we need to configure the OSM client to access the MBI Ingress. So is by default in the past we were using we could access to the OSM using localhost, but right now we need to access to the OSM client adding specifically that endpoint. So in order to access to OSM, we need to expose the hostname. Here in this case, you see that the OSM hostname is pointing to this MBI Ingress. And thanks to that, I could check, for instance, what are the Beam accounts or the cloud accounts that we have. Oh, sorry. Let me show you here in another example here. So here, OSM list. Yeah, you could check here that we don't have any Beam, or we have, I could check, for instance, an F package list. Probably I don't have anything, or I don't remember if I have anything or not. Yes, there is a network function here that we could see. Okay, so well, this is the typical behavior, but just bear in mind that you need to export OSM hostname if you want to use the OSM client, right? Besides that, the other thing that we have done is that we have made the Git repos accessible through well, we have right now Git repositories. They are accessible through Gitea, the UI that Gitea provides, and also in the OSM server. So let me illustrate that. Okay, when we have an OSM installation, and let me share my screen now. After OSM has been installed, there is well, you have a Git application that I could show you here, for instance, right? It's here. This is the Git application. You see here that it's pointing to the ingress, okay? That it's from Gitea, so I could check the ingress again. Yeah, you see here the Git ingress. And but we need to log in, okay? What are the credentials? What credentials do we need to use? So whenever we install OSM, there will be a folder that is here that it contains credentials and some other stuff that is created during the installation, right? And you could check the credentials here in this Gitea environment, okay? And we could check and go to use the standard username, OSM developer, and the password. So I'm going to put here OSM developer and the password that was provided, and I could just log in here. Okay, and you could see here that these are the repositories that we created. Okay, at the same time, a copy of these repositories is located here. So we have here the Fleet OSM and the Software Catalogs OSM that are the two repositories that are created during OSM installation. Okay. This information is captured also in the slides. If you are interested, you could check that. But you see here that all the credentials to access to Git repos in that file, and the Git repos are located there. Okay. Well, so we have shown the ingress. We have shown also the Git repositories that are created and how they are accessible through the UI. Now I think that it's turn now to move to the demo of some of the new workflows that were added in OSM. So I'm going to illustrate three workflows: the Beam account or cloud registration, the cluster creation, and also the deployment of an application. I'm going to start with the cloud registration. So let me just launch the command and I will explain what's going on. So I'm going to just share again my screen here. Yeah, now, okay, so I'm going to, well, first of all, I'm going to interact with OSM, so I need to make sure that I'm using the environment variable. So I'm putting it here. Let me show you that there are no beams yet here, and I'm going to add one of them. The beam that I'm going to add is an account, a beam account or a cloud account from Azure. all the credentials are in this folder that I'm sourcing right now. And now I'm going to run the command that it's here, and I will explain what's going on. Okay, well, this command is adding a Vim account that will be called Azure Dev. In the account type is Azure. And we are using the credentials that are stored in a specific file that is private, that I'm not sharing here. So that's why I'm using environment variables here. And also I'm specifying a description and some configuration, default configuration, the default region name and the default resource group, right? And apart from that, I'm also sending the typical credentials that are obtained from Azure. Okay, this is the ID that is returned by the client. So what's going on right now? Okay, so let me explain what's going on, because this is common to all the new workflows in OSM. And well, I'm going to start with this example so that you could understand pretty well what's going on. So once the request is received in the MBI and is sent to LCM, LCM will do the following. We'll create an Argo workflow that will be in charge of doing the specific tasks of this operation. In this case, it's basically registering a Vim account. But in all the cases, in every case, it will be the impact will be slightly different. I mean, the things or the tasks to be done are slightly different, but the workflow is pretty similar. In the end, this workflow, what has to do is publishing something in a Git repository, adding some files, updating some files, or removing some files. In this case, adding some files, and Flux will get that information from the Git repository. And that's what's happening here in this screen here. Well, probably it's going too quick, but you will see in the next iteration. But you see here that this is this is telling you right now the the progress of the operation. In this case, this is a screen that is split into 4 subscreens. We have first of all the workflows that were launched. You see here that the workflow succeeded. Okay, let me share. I think that I'm not sharing my screen. Let me show again now. Now, I think that now it's here. You see here this is the screen. It's split in 4. In the top left corner, you have the workflows that were launched. In the top right corner, you have the latest workflow. We could see that the workflow completed. It first created some volumes, cloned the repositories, then added some files, did an appropriate task, okay, and finally pushed to the repository. And also here below, you have the synchronization of that it's happening right now with Flux. So you see that there are some things that say that are false, so they are not yet properly synchronized. That's why it's captured here as false. And when Flux finishes, right now it has finished, we see that the changes have happened. So in every new workflow in OSM, it's always the same. We are making some changes, pushing them to the Git repository, and Flux is reading them and making sure that they are applied to the appropriate clouds. In this case, since we are not applying anything to the cloud, just only registering a cloud, it has completed now. And we could see if we check here sorry, let me just remove this so that it's not confused. If we check right now the list of VIMs, we will see that the VIM is there and it's enabled. So let's add right now or create a cluster. This will take more time and it will give me some time to illustrate what's going on. Okay. So the cluster that we are going to create is going to be called Demo1. It will be based on a standard size, a standard D2V2 VM size. It will have 1 node. It will be created in North Europe and in the resource group OSM CTIO. This is the cluster create command that I will use, and I'm right now launching the creation of the cluster. You see that I have specified the version 1.29. So that's the version of the Kubernetes cluster I will create. And let's see here what's going on. We see that a new workflow has been created. This is workflow, it's called create cluster, and this is the identifier of the operation. And we could see also the progress of that workflow here. We see that the workflow, the repos are being created, the volumes are being created, and right now we are cloning some repositories that are used in OSM. In this case, the software catalogs and the fleet repository. Okay, this window can also be shown here in here. Okay, so we have here also the workflow that is running. There is a new UI for that, and you could also check the progress of the workflow. You see that the software volumes repo and the fleet volume repo were created. The software catalog was cloned. Also here the fleet, and create cluster, and finally push to fleet. It has completed. It has completed. So if we check here, we see that the workflow has succeeded. But now it takes some time to create the cluster, okay? Because Flux needs to be aware of that synchronization, of that change in the Git repository, and then finally, well, the cluster needs to be created, and that takes time. So if we check right now, for instance, what's the situation with the cluster, what's the status of the cluster, we could see that there is a cluster. Let me make it slowly like this. We see that it's the demo one is created from the point of view of Git. That's why the state of the resource is in progress, because the cluster is in progress, but at least we have the synchronization with Git, and it's processing because it has not yet complete. So let me go back to the slides so that you could understand again what's going on right now. So we were commenting that this was the workflow. Let me illustrate this workflow in a different way. So we have created new MBI operations for all the new first class citizens, for clusters, for profiles, for OKAs, for KSUs, okay? The things that Francisco Javier commented before. Whenever there is a new MBI call, obviously we have all the role-based access control there, etc. Then the MBI sends the request to Lifecycle Manager, and the Lifecycle Manager will create an Argo workflow. Okay, so it will push an Argo workflow that will be executed in the management cluster. And that one will basically be doing a change in the Git repository. And finally, that will be synchronized by the Flux, by Flux system. Okay. Let me show you, well, if this is true, we should see a change in the Git repository, and that's true, okay? That's why if we go, for instance, here to the repository, and we check here this fleet OSM, and we check the latest commits, we see that there was one commit 2 minutes ago that was create AKS cluster demo 1 at North Europe. And we could check well, not only that, but we could even check here the changes that were done. We see here different manifests that were added in the Git repository, including here, for instance, the encrypted keys that are required for that cluster. They are in the repository, but here they are properly encrypted with SOPs. Okay. Well, so I think that probably this is still progressing, and we could see here that there is some synchronization here. So let me go back to the slides pretty quickly just to comment something, and I will wait for the cluster to be ready. So as I was mentioning before, LCM pushes a workflow, okay? This workflow lands in the end, creates some files or updates some files in the Git repository, and then is synchronized by Flux. And then Flux uses that information to synchronize in Azure. And that's what, sorry, in the cloud account, in this case in Azure. That's what is happening right now. And that's what the synchronization is happening at this moment in time right now. So it's worth to mention that all the workflows in OSM are exactly the same. So there is always a resources initialization, a clone, a repository cloning, okay? And what is different is actually the subtasks that are in charge of creating, updating files, etc. Okay? There are benefits of using Argo for that, and also, well, there is a good reason for the extractor of the Git repository. We have two repositories with an appropriate extractor in order to, well, manage that synchronization order that Francisco Javier was commenting. Okay. So let me share right now my screen, see if the cluster is already there. If it has not yet complete, I am afraid that I might need to pass the turn to Ramesh, and we could check maybe at the end of the webinar if the cluster has completed or not. Meanwhile, you could see, by the way, that there is a cluster here that is being created. Okay, so that's why you see this. I could probably go to here and check in the portal to see if the cluster is being created. Okay, so let me refresh the portal. You see that the cluster is being created, right? Cluster demo 1, but it's still in progress. That's the reason why it's not marked here as ready. And if we check here in our screen, we will still see it as processing. Okay, But well, after a few minutes, we will have the cluster running. So for the interest of time, I'm going to move right now to Ramesh Ramanathan, who will make a demo of a full 5G use case. All yours, Ramesh.
Thank you, Gerardo. So far we have got an excellent introduction into what comes new in release 16 of OSM, a true jump, where we bring in declarative operations to manage cloud native deployments. So declarative, of course, as we saw in the previous sessions, GitOps-based declarative approach governed by state, which gives you active reconciliation that helps you not just improve the management of your deployments, but take a giant leap forward moving towards autonomous networks. So in this part of the presentation, we're going to show the power of this OSM release 16 by doing an end-to-end automation. So what I mean by end-to-end is deploy the cluster that is going to host a 5G core, and then over and above deploy the 5G core as well. And to make it more interesting, bring in the different notions of profiles that we saw earlier on in the session, right? So when we talk about any deployment of any cloud native functions, there are going to be a variety of requirements for the infrastructure. For example, the cluster needs certain controllers pre-built in. It could be the number of worker nodes that you have, the number of the distribution of the resource groups across the clusters. So these are things that are configurable in OSM. But in this particular demo example, what we are going to see is a cluster deployment with two controllers, the Multis controller and the KEDA controller. So this gives you, so with this we have the right infrastructure to deploy the 5G core. And over and above that, we are going to deploy the open air interface, the OIA project 5G core, all the modules that make up the core to showcase the end-to-end automation. So to showcase the two controllers versing, when it comes to Multis, for the AMF pod, over and above the default interface that has been created, we are going to create one more management interface. And the same AMF pod, we're going to scale up and scale down using the KEDA controller. So in KEDA controller, it can watch, and based on certain policy, it can scale your cloud native deployments. So in this particular demo, we have kept it simple, where based on time, every 3 minutes, it scales up and scales down the AMF pod from 1 instance to 3. So this is our demo setup. So what we are going to do is kind of put it all together, right? What Javier and Gerardo explained in the previous two sessions. We are going to, this is going to be a cloud native example where we are going to do it on AWS. Of course, we support variety of platforms. It can be on-prem, AWS, Azure. Gerardo was showing some examples there. This particular one will run on AWS, where we'll have a Vim account in OSM for AWS. Then we onboard the required packages. So here in this example, as we saw in the previous slide, we'll be onboarding the Multis and the KEDA packages. So once that is done, we attach it to a KSU. So kind of do the transition from your catalog to your fleet git, and we get it into the KSUs. And then of course we attach it to profiles. So profiles, as we saw earlier, are your high level reusable components. So the power being, if I want to replicate deployments, for example, right, I can create new clusters with the ready-made profiles. So you get your automatic, replication of the software, the kind of state that you want in a declarative fashion. And once we attach the profiles, we go ahead and we trigger the deployment where Flux sees the changes and goes ahead, deploys the controllers in the cluster. And then after that, once the cluster is ready, we go ahead and deploy the application workload, which is our 5G network function. Right? So for the sake of this demo, from a time perspective, we will show you the creation process of the cluster, the controllers, the KSU, and the profiles as one track. But however, we do have one cluster that is already deployed for the sake of time, which we'll be using to deploy the 5G workload. So with this introduction, let me go ahead and log on to OSM. So to begin with, let's look at the Vim accounts where we will. So we have one Vim account set up in AWS, which is where we will be doing this demo. So with this, let's go ahead and create the clusters. So we have one demo cluster that is preset, as I explained, from a time perspective, which we'll be using to deploy the 5G. But however, we will walk you through the procedure to create a cluster. So,
Ramesh, are you showing your screen?
Oh yeah. Oh, I'm sorry. It's not my bad. Can you see now?
Yeah, it's good.
All right. So sorry about that. So just to rewind a bit, let's look at the Vim account. We have one Vim account that is set up, which we'll be showing in this demo, using for this demo. And then let's go to the clusters. So like I explained, we have one cluster that's already set up, which will be from a time perspective. However, we'll go ahead and create a cluster to show you the process. So we give a name. So we can give a version like Gerardo showed from the command line. We create choose the Vim account. We choose a region of AWS. Resource group. Node count 1, but to keep it simple. And then you can mention the node type here. So the Kubernetes version, naming the resource group, the number of worker nodes you want to create, and the node size. So with this, when we create, this triggers the cluster creation. So as the cluster gets created, let's look at the packages that we have in place. So we have, like explained earlier, we have two packages for this demo, the controllers for the cluster, CADA for auto scale in and scale out, and multi-CNA for creating multiple interfaces, which we'll be showcasing for the AMF pod. So each of this to quickly give you a walk through the packages. It has templates and manifests. So the templates manifest, if I were to walk through for Multis as an example. So it talks about what is the chart name, what is the reconciliation strategy for Flux. It's going to be based on the version number, the source, the Helm repo source, and then the installation instructions. Right? If the namespace doesn't exist, create one. Then what is the interval to watch, and then the repo.yaml where we give the path to the actual Helm chart repo. So this is your manifest. So in essence, we have given the Helm repository and the Helm release instructions, which can be used by Flux. And then in the template section, here is where your Kubernetes as a code construct comes in, where we mention what is your the Git repository, the source, where we are going to store the dry manifest, which will then go to the fleet with the configurations, right? So these are your manifests and template that are part of your OKA packages that we upload. So we have already uploaded the 2 packages here for sake of time, KDAN, Multis, and CNI, but just a matter of just composing a new OKA. So once that is done, we can create the KSUs. So here to add a KSU, so we have again 2 KSUs created on the demo cluster from a time perspective. However, I'll show you a new KSU creation. So name, we have description. So profile type. So this is a controller profile because this is going to be a controller on the Kubernetes cluster. So here I'm choosing a profile name based on what I have created. So I can select an OK here, and I can give transformation. So I'm going to just choose a multi-CNA as one of the OKs. And the transformation file here. So this gives you an opportunity to overwrite some of the configurations if you want as you upload it. And then if I hit create, okay, so one of the entries I think was, but this in essence the procedure that we use to upload the KSUs. So once the KSUs are uploaded, then as we saw the Git watch, as we saw in the GitOps principle, this is watched, observed, and applied onto the cluster. So let us go and look at the cluster now, which we had prepared for this demo. So right. All right, so we are logged back in. So let me go ahead and look at the demo cluster here. So in the demo cluster, we see the Flux, we see KDA, and then of course we see Multis, the controllers that have been installed in the in this demo cluster. So in this cluster, we are going to go ahead and we are going to install our 5G package. So if I were to go to the 5G packages, so I have the 5G OAI package that is ready. So to just give you a quick look, this is the VNF. So in the CNF package, so here we have given it an ID, which we can map it in the NS. Right. So just to go back to the NS to give you an idea, we see the VNF ID, the CNF ID that is mapped to create the NS. So this is a OAI package that has all your the 5G code. So I'm going to go ahead and initiate this. So creating a sample NS. So with this, I'm going to go ahead and create the NS. Right. So this NS is going to now deploy on our sample cluster. So let's go ahead and of course, before I go there, just to quickly give you a view of the UI in terms of the enhancements. So we have the K8 cluster, the repos, then the different app profiles that we talked about, right? The config profile, the controller profile, the app profiles, and the resource profiles, right? So these profiles can be attached to a cluster, and then gives you the kind of reusability that you would want to replicate a deployment across your different data centers or AWS regions. So with this, let's go and take a look at the status. So we have pods are still coming up, which have been installed. So the code takes around a few minutes to deploy. So if I were to, let's go ahead and so Gerardo, you want to show your cluster status as we wait for the 5G code to come up? Takes a few minutes to come up. Okay.
Can you hear me? I hope so. Yes, you see here that the cluster, well, that the synchronization in Flux has completed. So all the customization handles that were created, they are there. If we check right now, the situation with the cluster, we could see that the cluster is ready. We could, for instance, get the credentials of that cluster, get credentials, demo 1. And those credentials could be exported to a kubeconfig demo1 file. We could connect there and, for instance, export kubeconfig equal to kubeconfig demo1, and here run, for instance, kubectl get nodes, and we could access to the cluster that we created, and we could see that it's there. The version is 1.29. It's in an AKS cluster. We could also see that cluster here, and we could see that right now it should be running succeeded. Okay, so the cluster is properly working there, and we could even deploy applications there. I think that, I don't know if there will be time for that, but
We
could
just have
also.
2 minutes, so.
Okay, yeah, so I think that it's not possible, but you get the idea, right? That the workflow has completed, the cluster is created, we could get the credentials, and right now is there. So I think that we could probably go to the slides. Just we can comment pretty quickly that we have the ETSI software and standards for smart networks and services in November 2024 that you could register and join us there. And I think that if there is nothing else that we're going to show, I don't know if we're going to show someone else. Otherwise, I think that we could just thank you. Okay, is there anything else that you would like to show, Ramesh, Francisco, Javier?
I think we can. I thought we can probably use this 2 minutes for any question and answers. Anybody from the
I think that we need to close, Ramesh. We will answer the questions offline because I
Sure.
Emmanuel.
Yeah, well, if you want, you can take one question. I think it should be okay to have one question if you want. We should be all right.
Okay.
In time.
Well,
Okay.
there is a question here from Constantine. Yeah. Is it possible to deploy workload clusters on OpenStack VMs? Right now in release 16, we can deploy workload clusters on public clouds, Azure, AWS, and Google Cloud. In release 17, we will add the support for private clouds based on OpenStack. I think that there is also another question from Constantine about the Argo CD and Flux. I don't know, Javier, if you want to take that.
Yeah. The things that, I mean, Flux is used by OSM, so you will not see Flux in action. You need to operate Flux. Is OSM the one that is operating Flux? If eventually for manual operation you wanted to use Argo CD, why not? Just use it, but it's a manual operation that you are adding.
Mm-hmm.
Okay. I think that's okay. That's all for today. Thank you very much for the detailed overview of OSM release 16. We don't have so much time for more questions, but these will be additional questions will be addressed later by the speakers by email. Before ending, I would like to thank very much our presenters of today for enabling and presenting this talk, and also thank everyone for listening and participating in this webinar. The recording of the webinar will be available and with the slides in PDF shortly after the end on the webinar page. Stay tuned. You can check ETSI website for news about upcoming ETSI events and webinars, and also on ETSI Bright Talk channel. We've included a link to the event, the SNS for SNS event, organized in November in ETSI, in the attachment section, so you can check this out. And I think that's all for today. So again, thank you very much all. Thank you for interesting speakers today. And we'll see you soon to a future webinar.
Thank you.
Thank you and
Bye-bye.
goodbye. Thank you very much.
Bye.